We are today going to have a little talk with Obelix. So Obelix is going to show us something, and this is about 3D printing. 3D printing is really cool. 3D printing is supposed to be, as some people say, supposedly the new scientific revolution, and is going to disrupt major industry. This is really awesome. And we have a little question, though, and that is, what about all the waste? What about the waste that happens in 3D printing? And Obelix has thought a lot about this and experimented, and he usually doesn't come to any congress or any camp without his 3D printers. He's going to tell you about that, and he's going to show us or talk to us about what we could do to reduce the negative impact of the environmental impact of 3D printing. So please help me welcome Obelix.
Okay, thank you very much for being here. I think thank you for the effort for getting up this early. It wasn't easy for me too, but now we're here and we're ready to start. First of all, I hope my English is good enough. I thought I had submitted a talk in German, but it was English, so now I'm talking English. And so excuse me, maybe if I don't know a word, I will try to say it in German. The next thing is, in the beginning, when I submitted the talk, I had a lot of, I think I was a little greenhorn about recycling, and I had a lot of ideas, and at the end it turned out a little bit different. So we won't only talk about recycling plastic in the form of shredding it, like you may know it already, but also the global problem that emerges with 3D printing, together with the growth that this market and this industry has. So what are the goals for this talk? First of all, raise awareness for the issue, because you already know, especially in Germany, we have this really complicated waste management system, and we already have recycling processes for plastic, but these also will be increasingly used for 3D printing plastic. The other thing is to provide ideas and inspiration, because I already failed in some moments. I discovered some things and I want to share them with you, so if you try something, you don't have to start from 0 too. Yeah, so that's about the goals. First of all, what is the problem? Everybody likes 3D printing, everybody buys 3D printer. It's easy and cheap. A kilo of PLA plastic costs about 30 euros. So, for example, if I want to print out this little Winkelkatze, it may cost me like €1, so I don't care, it's just fun. And that's one of the problems. People like print a lot of stuff they don't really need. They just print it because they have a printer and they want to print something. I must admit that in the beginning I had the same problem. Sometimes I'm in front of my printer and I say, man, I need to use this, I want to print something. And at the end I end up printing thousands of vases or some other crap that I don't really need and only catches dust. And the other problem that comes with this is that there's no recycling infrastructure which is adapted for 3D printing. You have the normal recycling infrastructure where trash is collected and sent to recycling centers and then processed. But with 3D printing being a technology that is spread around the world and very local, there are chances to develop 3D recycling processes that are like the printer's local too. So for example, if you are able to recycle plastic without getting it out of town, for example, if you live in a small town, this uses less infrastructure, less energy, and has less impact on the environment, which is not possible with normal plastic, because who needs plastic pellets if you don't have a 3D printer? So that's a new dimension which comes into this thing. Yeah, about printing useless stuff. This is some of my useless stuff I print, just to give you an idea. These are the Stanford bunnies. One costs, I think, 20 cents, 30 cents. So I printed 60 of them because I found it funny. And now I don't know. Now I have them lying around and I don't know what to do about it. And this is especially hard because this is the plastic that is really difficult to recycle. But so that's the example for don't do that. Because that's not a good example and that's not good for the environment. So why recycle? Well, first of all, there's the environment. You want to think about it, you want to preserve it, so producing trash is bad. And that's the first reason why you should recycle or at least produce less weight. And then there is another point, is that trash is money. If you print stuff you don't need, you spend money while you don't need to spend it. That's the point where I started thinking about it, because I have huge boxes of plastic trash, and I started to think about how much money I'm wasting, as well as having them printed or just throwing them away. So that's the point where I thought, man, you need to change something. How does this look? This is about the plastic I have printed, the trash plastic I have printed in 6 months. So this is, these are big boxes. I think it's about 6 to 8 kilos of plastic, which I could have thrown away, but I collected them so I could do something more useful with it. So what happens with the plastic if you don't recycle it? Well, if you are lucky, it gets into a recycling center. If things turn out bad, and I say I would like to issue a graphic warning for the next picture, if you have a light stomach and don't like to see dead things, then don't look. Because this is the problem you have all day, especially in the oceans, animals dying because they have plastic inside and they eat it. And these are the size, like these bottle caps, or like even the Mate clips you print here. These are the size of chunks of plastic that animals can eat and will die because of this. So this is one of the reasons why this is really important, because it's sad and it's not cool for the animals. I don't think I need to really discuss why it's that, but that's an example in case of if you weren't aware of it. So some numbers about this. 3D printing is around for, I think, around for a long time. We have reduced, but since 2005, the beginning of May, we have really seen a rate for everyone. So even in Ireland, machine costs below $5,000, or €500. So in 2015, we have 200,000 printers being sold, and this. Sorry? Sorry, I acoustically didn't hear the question. This is worldwide, yes. So this is an estimate. There's an exact number I took from Gartner. I think they're an institute for statistics and market analysis. And they estimate that will grow and really grow fast in the next years. Yeah, it's a $1 billion industry. Actually, the market value is around several $1 billion. And is estimated to reach about $20 billion in 2020. So there will be a lot of things happening, and it's good because this technology has really good advantages. But with more print, there is more waste. And one of the problems is the failed prints. You always have fails, like with normal inkjet printers. You will never be able to reduce completely or to eliminate them completely. But there are two categories in this failed prints and two different things you can do about it. First of all, there are the failed prints that fail because of technical problems of the printer. So how does this look? This, for example, looks like this. Yeah, I could have said that this talk could have also been in philosophy. But this, for example, the prints didn't completely stick to the print bed, and this is about 10 euros of wasted plastic. And it's waste that is produced for no reason. So that's one of the first problems. Another picture could be this one. I have a lot of them. I could show you like about 1,000 pictures of failed prints. And this one. That looks really funny. Yeah, that's funny now, but if you have to give a print to someone and he's waiting for it and you're sending him this picture, he wants to kill you, you know? Yeah, that's one of the reasons it fails, and this, I think, it's most of the fails. At least for my part, I print, like, if I print 1 kilo of material, there are 100 grams of waste. But the other part is where you print because, for example, you have done the wrong measurements, or you have chosen the wrong file, or some else reason. So this is a human error you make, but this also counts as a failed print. So that's one of the problems you also have while 3D printing. So the goal is to reduce, one of the goals that you have is reduce these failed prints. And that's, I think, one of the biggest, the best goals, because like for energy or electricity, you can try always to produce cleaner electricity, or in this case, better plastic. But the thing is, if you just start using less, then you also have to throw away less. For example, you can see it here. The infill of the prints is really high. I mean, it's like, I think, 20%. And this was for an architectural model, so it doesn't need any stability. I could have printed it without any infill, and it would have been much more lighter. And that's this kind of human error that can be changed, and you have to be aware of it, that you can really save a lot of plastic by doing this. So during the next, there are many different ways of recycling plastic and recycling these prints. For the next time, we want to focus on one technique, that is the threading technique. You may already know or have you seen on TV. So this, how it should work. This sounds really easy. You collect the stuff, you put it in, you collect it by different material types. So you put in PLA in one box, ABS in the other box, and everything is fine. Then you clean it, because you have to remove for example, if there's dirt on it or something, you want to have really a clean material. This is a step that many people forget, but it's really important because that augments a lot the quality of the filament you extrude at the end. Then you buy a shredder and destroy everything you find, because it's a lot of fun. Yeah, no, really. I had one in the office, and at one point I was looking for a smartphone, and for some reason I looked at the shredder immediately, thinking, did I shred it or not? But I found it. It's okay. It's here, you know. No, but that's the fun part. You get to destroy stuff. And the next step is also something people forget. You have to filter the parts by size, because you want to have all the parts in the same size. That's something we'll talk about it later. Then you have to buy or get a filament extruder. Filament is, you can see it at the 3D printing assembly. Everything I'm talking about, you can see it at the 3D printing assembly. Filament is the plastic that goes into the 3D printer in case of FDM printing, and that is heated up in a nozzle so it can be put on the build plate. So these have diameters of 1.75 millimeters or 3 millimeters. So it's like a hot glue gun. You just put material inside and you make it hot and press it through a nozzle, and then a filament comes out. It sounds really easy too. Yeah, and after that, you can print stuff and you can repeat this. This really, I mean, I saw that and I said, cool, I want to do that. So what are the machines we need for this? First of all, you need a material extruder. This is the machine I bought from Nostec. You don't have so much machines on the market. This is the only one which I could find was already assembled, because I didn't want to waste my time building the thing. I wanted to use it. So I bought a completely built one. It's really simple. You have a huge electric motor, which then pushes the threaded plastic parts, which are here, through a long thread that's heated up in the front, and then the plastic filament comes out of it. Sounds easy too. Okay. The other thing is the shredder. As you can see, it has already some funny stickers. Yeah, so you put the plastic in the top. It's not electric. It doesn't work with electricity. You have to use like your muscles. So you have to eat a lot of soup and drink a lot of beer. But it's really fun. I have some people that only come because they want to destroy stuff. So that's really cool. They come and ask me, can I shred stuff? And I say, okay, if you don't break anything. But so that's a fun part. You get, I mean, the principle is really simple. The plastic goes in from the top and then comes out in little shreds. And here you can see it already. The parts have different sizes. You don't want that. So, seems pretty simple. Why shouldn't this work? Oh, that's what I thought. But I bought everything, I tried it out, and then I had to realize that it's not like it seems to be. First of all, why didn't it work yet? You know? shredding stuff is really complicated, and because the prints are really stiff. I mean, you want to print something that resists a lot of force, so shredding the stuff is complicated. It's really with the small shredder I have, I can't thread anything that is thicker than 2 or 3 millimeters of wall thickness from a print, because you don't just have enough force. So one of the techniques is to break it down a little bit with like your hands or on a table corner with your weight. You can break it, make smaller chunks, and then shredder it. Then the different sizes of the plastic, that's a problem because you're pressing them into the extruder, and if they have different sizes, you absorb into the machine. You absorb a different number of particles in time. So your flow at the end is varying a lot, and this results in a lot of irregularity in the filament thickness, and that's not something you want. You really want to have a clean filament with a constant thickness. And then the cleaning process needs to be optimized because when you melt the plastic stuff, you don't want to have water or humidity inside it, because it will be included in the filament, and it may make holes or bubbles inside, which is really a problem for 3D printing. So this is the first problems I ran into with the system, and that's really, these are some points that are not easy to resolve, because the problem also was to find a shredder at least that works, because if you Google for shredder or look on eBay or Alibaba, you find like shredders for papers, and if you want bigger, then you find shredder for cars or like tires. And so the paper stuff was too small, and I didn't have 50,000 euros for a diesel shredder that can like take huge tires. So that's one of the problems, that you only have one machine that really works, and it's not so big. So that's one of the really problems that I ran into. How does this shredded plastic look like? Well, you can see it here. That's really, I mean, so many people ask me about the colors. Why don't you mix them? And why do you mix them? Why don't you sort them by color? I mean, I could, but then I have to have like 50 buckets per plastic, and that's too much. I don't care about the color. If the recycled print is gray, then it's okay because it's recycled. So this is something that has run several times through the shredder itself, and it's still not the same size. And this is really one of the main problems. But okay, everything looks, and I tried to shredder this with a kitchen mixer at home. It works, but it makes a lot of noise, and then the shredder is broken. You see all my my fellow roommates who all they facepalm because now I need to buy a new mixer. But I mean, so I tried different things, and I cannot recommend to do it in your mixer at home. I will drink something, sorry. Okay, but this looks something you could solve. I mean, you could just buy different shredders or clean it better. But how about the problems that you can't really solve at home or by yourself? Well, there are, especially for PLA, a lot of misconceptions about the biodegradability. So people say, man, I print PLA because it's good for the nature. It can be, if it decomposes itself, and many people think this, but the problem is that PLA only decomposes under industrial conditions, and in the nature it behaves like any other plastic, so it stays there for 5,000 years. That's really a problem. I mean, there's many plastics like this, and why should it decompose in 3 months? I mean, if you print something for your garden and it disappeared 3 months afterwards, that's not what you want. So that's really the thing, that you want to have a durable product. You want to print stuff that holds 2 or 3 years, even in the sunlight. So it's not really possible to make them biodegradable, so they can really in the nature be left with no harm, like food or normal biological waste. The other problem is that many of the plastics you buy, for example, these from Color Fab, they're not pure PLA. They're mixed with other stuff because that makes them easier to print. It makes them smell like sugar or coffee. It's not a joke. You can really buy coffee filament that smells like coffee while you print it. It also exists. Yeah, I don't know why, but I mean, okay. You also can buy beer filament that smells like beer. Yeah, I'm really waiting for something that smells like, I don't know, mint or strawberries. So there are many people putting many weird stuff inside of the filament that really changes the chemicals of the filament, especially regarding the biodegradability. And the other thing is the special filaments. Well, you have special filaments, for example, with metal particles inside, with many other, like wood, cork, or what do they have? You have the flexible filaments. So they are not normal PLA, and you need to separate them for the rest. But there's even, because they're less around, so there's even less experience with recycling of them. And another problem that I've already talked about is the precision of the extruded filament. Because if you look how they do it in really big industries, in China, for example, where they make tons of filament per day, they extrude a really thick plastic rod and then pull it while it's still warm, so they can really adjust the perfect thickness. This is a machine that would fit in this room, so it's nothing you can buy at home or transport with your car. So, but I mean, then it depends. I mean, if you have a lower precision, maybe you can adapt your printer to it, or just, I mean, if it's a recycled print, you have to make some kind of sacrifices. Maybe that's one of it, so it doesn't look perfect. So, and okay, now we have seen that recycling plastic isn't as easy as I thought it would be. I hope I'm not alone with the thought, because I talked to other people and I said, no, it's totally easy, safe, try it. So, okay, you have a 3D printer and you think, this is too complicated, I don't want to buy stuff, I don't want to be bothered by shredders or stuff like this. So how can I really try to reduce the trash that I produce with a 3D printer? Well, that's something I already talked about in the beginning. You have to adapt your prints, because now that I know that they're really difficult to print, I will print my parts with less stability, so I can easily shred them and they use less material. So there are two parameters you can adapt: infill and thickness. People are printing objects with 30% infill. I don't know what they want to do, fly on the moon. Even with 10%, prints are really hard enough. So you can print with 5 or 10%, that's really enough, and you don't need more than 2 walls. So most of the time you can really, you have to test it out, what for your printer works best, and then you can really easier recycle them and use less plastic. Then the really important part is think before you print. I always get emails within the signature written, please don't print it out unless you really need to. This could be transferred to 3D printing too. So if you come, for example, to the 3D printing assembly and I give you stuff, please only take it if you really want it. Because I mean, I don't have to print them, I only print them because people take them. So if you are not sure if you want it, then maybe you should leave it. And then the other thing I already mentioned is reduce the failed print rate. So how can I do that at home? Well, the best thing is that you get to know your 3D printer, you get to know the moment when it fails, and you need to really make sure on a regular basis you check it, you check the screws, if everything is tight or if anything is loose. And that's really easy steps to reduce the print rate. If in 1 month, if you have a 3D printer and each month you spend 1 hour checking the printer, you will really have much less of failed prints. So that are really some easy steps you can do, and I think you can really save a lot of plastic by doing it. Well, we have 3D printers around now. We had them for the last 10 years, but what about the next 10 years? Because we are now talking about FDM printers. So FDM is the technique where you have the nozzle and the plastic is extruded. This is actually cool because it's cheap and everybody can build it easily. The RepRap projects can build it easily. But I personally think, and others may join me in this idea, that this is not the future because it has a lot of limitations and requires, I mean, you have a lot of problems that come with a print that you don't have with other techniques. And you have other techniques like selective laser sintering or stereolithography, which need extreme powerful lasers like 200 watts, 400 watts. So this is something that won't be done at home in the near future soon. But one of the things that could be the future is Stratasys has a patent on it. It's called PolyJet. You have Epson also has this kind of print techniques where you have a resin that is spread on the print bed through inkjet nozzles, really on a microscopic scale, and directly hardened by UV light. This makes the machine work like a normal inkjet printer. You have to buy cartridges and put them inside, and you print, and you can take the print out. This has technically a lot of advantages, and I think that in 10 years this will be coming forward because there will be more research and machines will get cheaper. But why is this different? Well, FDM printing uses thermoplasts and polymers, which can be easily melted again and put into another forms like shredding them and building new filament. But what about the resin that has been cured with the UV light? Well, it's not as easy, and that's where the problems start, because actually if you want to recycle resin, you burn it and you take the heat for doing it in other purposes. I don't think that's a bad procedure. If you filter the air correctly so it has a low impact on the environment, you still take the best out of it by using the energy kept inside to produce heat or energy. The other thing that you can also do with PLA, but also with resins, is chemical decomposition. So you have to collect them and put them under certain conditions so you can extract the polymer chains or decompose it into its chemical parts and then reuse them or throw them away in a responsible manner. So these are the other recycling techniques, and I didn't find any other. Maybe someone has another idea, but this is it. So, and the problem is that with the extruding of the filament, if in 10 years we don't have any filament printers, then it's useless. So we have to find other ways, and I think that's the only way then is reducing the failed print rate. So why am I talking about this? Because at the beginning we said, well, you already have infrastructure for recycling plastic. You can sort it and throw it away. Well, while recycling, the idea with extruder could be that you recycle plastic on a local scale. So this is the only thing that you can do at a local scale, because the chemical decomposition and burning it, that only works in big industries, because you need all these machines and you need connection to the power grid. But if we find a way, either in the next 10 years, to also either recycle the resin printed parts easily at home or in local stores. I mean, you don't have to do it at home. If a local store can do it, it has the same advantages. Or then produce resins that can be easily recycled. So that's are the goals for the next times, the next 10 years, the next 20 years, and this is the idea I want to spread. Maybe one of you has a cool idea and want to come up with it. So what else can we do? We saw that we can recycle, we can reduce our print rates, we can pay attention. These are all things that you have to do if you want to do it, but you will never be able to produce 0% of waste. The other thing that is, if you extrude filament, because the filament is getting older, you always need to put new plastic inside, so stretch it a little bit with new PLA so that it doesn't break completely. That's something I forgot to tell in the beginning with the misconceptions. that people think that just because you extruded the plastic makes it a new one. If you take the Winkelkatze you had standing in your garden for 2 years and then extrude it, the plastic is still 2 years old and on a chemical base, broken, I would say. So that's one of the problems. You can't do it on an infinite scale. At some moment, you have to throw stuff away. So what else can you do to reduce this kind of trash? And that's no magic. That's just ideas I came up with because other people didn't have them, and I want to share them. So you can use the remaining parts. For example, the filament is put on spools like this, and the spools at the end of the print, they remain. You don't know what to do with them. You can put cables on them, but like in this part, you can also build lamps with them. This is a LED lamp, which makes nice light. So this is something you can do with the leftover parts from 3D printing. Also, someone else at the 3D printing assembly took some of my leftover filament and built necklaces out of it. And in front of the Angel area, you also have a huge sticker walls where some people put on recycled parts so it looks nice. Sorry. So this is, you always have to think out of the box. So if you have stuff lying around, it's like, can I recycle it? Or maybe can I use it for something else? And the other thing is, for reducing the print rate, and this is something also applies to this kind of lamps, and we said in the beginning, if you have the technology, you must use it. Well, even at the assembly, people come to me and want to have stuff printed that could easily be cut out with a knife from, for example, a paper sheet or a plastic sheet. So you always have to think, does the problem I want to solve with 3D printing is really being solved by 3D printing fully, or is this only a half solution? You read a lot about printing houses. I don't know if it's really the best thing to do, because you have a faster way to build a house than printing it. Yeah, I think IKEA has this kind of houses that pop off. You can like buy them and pull on 5 wires, and 10 minutes later you have a small house. Yeah, that really, I mean, that takes 5 minutes, and if you want to 3D print a house, you need a huge machine and extrude a lot of material. So this is something you always have to think about. Is this really useful, what I'm doing? I mean, I don't know if this is really useful. It looks really nice, but at least I didn't throw away the spools. So this is, and the LEDs I put inside are also reused from another project, so it's like 100% recycled stuff. Okay, but so we talked about recycling ourselves, but is there already other projects doing this? Well, there is one bigger project, a commercial project called Refill. They're from, I think, from Holland, and they get soda bottles and car dashboards made of ABS, and they trash them with big shredders and recycle them with filament. So you can buy PET and ABS filament from them. I even have some over there at the 3D printing assembly. If you want to take a look, you can come and see it. I didn't find any. I mean, then you have smaller projects which basically are for building the machines. So there is a filler extruder, filler boards, Lyman extruder. You will find, if you Google filament extruder, you will find a lot of people building extruder themselves with stuff you can buy from the normal Home Deposit or hardware store. But the question is the self-built machine really performing, or are you still producing more trash? So you can always ask this question. But maybe in the future we will see more projects emerge. Yeah, so this is basically the end. I'm sorry I'm not able to talk longer because I wanted to present more stuff, but because I failed a lot, I have nothing to present here. But we have a lot of things at the 3D printing assembly. You can just come over and check it. We have all the machines there. We have shredded plastic. You can use the shredder and like break stuff if you want to. So that's for the talk. Thank you very much for listening.
Thank you, Obelix. We now have a chance to ask questions. So if you have questions, please go to one of the microphones in the end of each aisle, so the back microphones. Yes.
Yeah, okay.
Yeah. Thank you very much. I have a question. So you try to you try to recycle, but isn't there a possibility to use some organic plastic, so that you can throw away?
Yeah, that's possible, but the thing is, if the organic plastic like decomposes, I think that's what you mean, then you can do that, but you really have to be aware what you print and how long you're using it. So if you're printing a smartphone cover, you don't want to use this kind of organic stuff. But for example, if you're printing Matetech, which you only use at Congress, then you can use it, because if 2 months afterwards it's like decomposed, then you don't care. So that would be a possibility. But that says that you know what you're printing, and you have to know it. Many people sometimes don't know; they don't just print stuff, so you have to think about it. But yes, I think that's possible.
Okay, so there's not already kind of organic
no,
plastic.
No, I didn't find anything yet. So
okay.
I think that in the future, with the growth of the market for filament, it will be like for inkjet cartridges. I think in 10 years, people would like give you printers, and you have to buy like for the double or the a really high price the cartridges to print inside. So I think there will be a lot of research done in the future, but this is really something first people with chemical knowledge have to do, and then they have to talk with the 3D printing people if it works. So this is a long process, I think, but hopefully this will work out.
Okay, do we have a question from the internet?
Someone is asking if you have estimated the overall cost of the recycling, so the energy you need for recycling and environmental costs you have with the recycling and so on.
I can tell you the cost of the machine. So the filament extruder has cost about 1,000 euros, the shredder about 700 euros, and then I bought like some accessoire stuff. So I would say that to start you need 2,000 euros. But for the environmental impact, these machines all consume the filament extruder electricity like 3D printers. But this is something I would put aside, because you have this environmental costs at any point. So if, for example, you don't recycle it and get it transported to a recycling facility, then you have the transport impact, the energy impact of the transport. You can put it in an account, but the recycler itself doesn't use more energy than the process at this point, because of the hand-used shredder, doesn't use more energy than a laptop, I would think, or maybe a big laptop. So, and this is not something that runs 24/7. It like runs for 2 hours, you recycle some filament. So the energy impact from the electricity side is really low. From the footprint of the produced machines, that I don't know. I don't know how complicated it is to build an extruder, how much energy it takes. But I think this is a level of detail where it's really complicated to make fine calculations and say this has produced how many CO2 and electricity. So you have to stop at some point worrying about the impact. You can go at a certain depth, but at some point it's getting too complicated.
Okay, thank you. And a question over here.
To save material, you suggested to reduce the infill, but doesn't this increase the failed print rates because of tipped over models?
I don't think so. Most of the time, the models tip over because the heat, the adhesion on the heat bed and the build plate is not good enough. So to prevent the tipping, this is what you meant, right? So to prevent the tipping of the models, what I always do is when I start a print, I really look at the first layer if everything is perfect. Because if the first layer is perfect, then you don't have to worry about it. A bad thing is to like start it and come back 5 minutes later, because then it has maybe failed and already extruded plastic. I could show you horrible pictures of printers that have run like for 40 hours and I forgot to look at them, and they have started making like a lot of spaghettis. So really, it's a good thing to, at the beginning of the print, you look at it. You can if you do a lot of 3D printing, you will directly see if it works or not, and then you can leave it. Then everything is perfect. But the first layer, you should stay there and look at it.
Thank you.
Any more questions? Are there any questions? Where can we see you today doing 3D printing?
I'm at the 3D printing assembly. So the 3D printing assembly is next to the Sendezentrum. I think you know where this is, but you can also look at it on the C3nav, I think, the navigation system for the Congress. The house name of this room is Garderobenfoyer Saal 1. So if you know where that is, I didn't know it too, but now I know it. The easiest description is when you come in, just walk straight to the elevators after the cash desks and go up with them, and you can't miss it. It's usually where there are a lot of people, and so yeah, we have a lot of 3D printers. And if, for example, you need a part to fix something you don't want to throw away, then we can print parts too.
Really cool. Thank you.
Is there a question from the internet? I don't know.
Yeah, thank you.
Cool. Sorry.
Another question from the internet.
Yes, there's one more question. Someone's asking whether there's a difference between cheap and expensive filament in terms of recyclability.
Sorry, the last word?
Recyclability, whether you can recycle it at all or how good it recycles.
Oh, that's a good question. I personally don't know. I would say that in terms of waste production, the difference between good and cheap filament is that with good filament, your prints fail less often, or they directly look like you want them to be. So, but what you really want to look at, if you want to see the recyclability of the 3D prints and the filament, is look at the components. So, depending on what kind of, maybe you have to ask the manufacturer, what are they putting inside too? Maybe they won't tell anything, but maybe they will tell you, okay, we also have pH or PET or I don't know, beer inside, and then you can see how these other polymers can be recycled, and this really has an impact on the recyclability. But that you have to ask the companies, because most of the time they won't tell you, because that's a production secret. That, you know, these little additions you make into the filament are the thing that make the best filament. So they won't tell you, and this is a difficult part. Maybe this changes in the future.
Any more questions from the internet?
Okay, if you're too shy to ask, sorry, yeah?
There's two more questions actually. If you have time, I'm gonna.
Yeah, we have time, I think.
The first question is do you recommend any suppliers for good filament?
I don't want to make any to put someone in the front, but I can say that I order my filament at Colorfab and German RepRap. Mostly because they have compared to I have made good experience with them. I wouldn't say they're the best, but that's why I order my filament. Yeah, but you have to try it out. It depends where you live. For example, I think Colorfab and German RepRap. If you're based in the US, you have other suppliers. So this is really more for the European market.
Okay, thanks. And then someone is wondering whether it's would be possible to just melt the whole waste into a big block and then proceed from there instead of shredding it first into a small part.
Yeah, that's possible, and that's partly happening in the filament extruder, because the whole barrel is made of steel, and when you heat it up, at the end it gets also warm, so that the plastic is already a little bit, I would say, weak and soft, so it can easily be sucked up in the machine. But I think that if you melt it in a big pot like this, you have to pay a lot of attention to the temperature, that it's constant over the whole part. I don't know, I haven't tried it, but I think it would be possible, but the machines will look differently, and I didn't see a machine that makes this. You can build one, you can try it out, it's not dangerous. If you recycle ABS filaments, please only do it in a ventilated area, because ABS filament is toxic and produces toxic fumes. We only print with PLA. So if you want to try out recycling, maybe it's a good start to use PLA, so you don't get any health damages or die because of 3D printing.
Sounds like a good advice. Anything else from the internet?
Yeah, questions actually start to pile up right now.
Okay, but also in the room, if you are too shy to ask a question now, you can also come later to the assembly and ask me.
Someone's wondering whether you can sand down the bricks so you get really, really small parts for recycling.
Sorry, what should I break down?
Sand down, runterschleifen.
Yeah, but you can sand them down. You mean so they can easily get into the shredder.
I'm not exactly sure how this question is meant, actually.
Okay, but I mean, sanding and 3D printing, from my experience, is only for cosmetic applications. If you want, I think what he meant is to produce a sort of powder you can easily extrude maybe with the machine.
I think so, yes.
Yeah, but if the parts are too small, then there's no grip in the machine. So you need a minimum and maximum size. So I think what you need are different stages of shredders, like a big one, a small one, and a tiny one.
And then someone's proposing that the hackerspaces could make a filament and sell it and make a local market and things like that.
You can. I mean, there are a lot of things that hackerspaces can do on a commercial basis. But in experience with my hackerspace, this works, but it only works if everybody feels committed to it. So from the hackerspace community, I know this works really fine for fun, but commercial projects, it depends on the people, you know, that people don't maybe go into hackerspaces because they want to do commercial stuff. But maybe there are some hackerspaces where there's a team that they want to do a startup and like you have a coffee bike, you can do a PLA recycling bike. I don't know. Yeah. You drive to the customers and you collect the trash. But you don't need to recycle. That being said, you don't need to recycle 3D printed parts. You can also take PET bottle and shred them and then print with it. That's also possible. So you don't even need to buy trash or filament. You can do it. Mostly it's written on the bottles. PET works fine.
Is that for the internet? Is that all for the internet?
Yeah, that's everything.
Okay.
Great. So, as we heard, if we have any more questions, we can find Obelix upstairs across from the Sendezentrum in the 3D printing area. And if there are no more questions at this point, then please give a round of applause for Obelix. Thank you.